Okay, so today we're going to try one of the questions on the cache memory. So the question is as shown in the screen, a byte addressable computer. So means each location is equals to 1 byte of data in your memory, has a small data cache, okay, capable of holding 8 32-bit words. So they're able to hold 8 32 bits words. So in 32 bits, they will have 4 bytes, right? 1 byte equals to 8 bit. So 32 bit will equals to 4 bytes. So means they will total hold 32 bytes of data, right? The number of bits for the tag line number and also the word. Okay, so from the question, basically you can know the number of words first. Okay, so the number of words is basically same as the block size of the memory. So they are telling you each cache line consists of two 32 bits. So the cache line size will equals to the word size. Okay, the cache line size is basically your word size. So they said two 32-bit words. So they have two 32 bits. So 32-bit equals to 4 bytes, right? So you have 4 bytes. So it equals to 8 bytes. Why are we referring to byte? Because they are mentioned that it's a byte addressable. So every location equals to 1 byte of data. So now in one cache line, they will have 8 bytes of data. So it means they have 8 locations in one cache line. So 2 power of 3 will equals to 8. So this W need 3 bits. So by this way, you're able to get the W equals to 3. Then the next one is the line size. Okay, the line, which is the R. The next one is the R we want to look at. So they are capable of holding their small data cache. They're able to hold 8 32 bits. So they're able to hold 8 32 bits, same the 4 bytes. So total they are equals to 32 bytes. So 32 bytes, then every line equals to 8 bytes. Right? Every line equals to 8 bytes, so you just divide by 8. So you will get 32 divided by 8, you will get 4 lines, right? So 4 lines is equal to 2 power of 2 equals to 4 lines. So you need 2 bit for your R. Okay, then it mentions to you, they didn't mention the address has how many bits, but they give you this is the address number. So we just assumes that they have a 3 hexa number in total for the address. So which is 3 times 4 equals to 12 bits. So they should have 12 bits of address line for the whole memory. Right? They didn't mention how many how many bits in the data line. So we just assume this is 12 bits. Then using 12 minus this 2 plus 3 equals to 5. My 12 minus 5 you'll get 7, right? So total you have 7 for the tag, 2 for the lines, and 3 for the word. So now you have already get everything for this direct mapping, which is 7, 2, and 3, right? For tag, R, and W. The next step is to divide all of this thing into convert them into binary and divide them into tag, line, and also W, word. So I have done this in the Excel files. So you can look at the Excel file, which is this one, right? Is it the same as the one in the word questions, right? So if you look at it, 500, 514, 328, 33C is everything exactly the same as the one in this sequence. So now we have break them into the tag line, the line number, and also the word. So this is basically the tag, and this is the line number, this is the word. Okay, so convert them to hexadecimal, convert them into the binary. So it is easier for us to refer to whether they're in which line, right? And this, let's assume this is our catch, right? So let's say this is our catch. Okay, our catch. So this is our line number. We have 2 bits equals to 4 lines, line 0, line 1, line 2, and line 3. And every line they will have the 8 byte of data, right? Every line will have 8 byte of data. Why is that 8 byte? Because your W equals to 3 bits. So means they will have total 8 locations inside one line. So the first thing, line 0, the 500 will put into line 0 because the line number is 0, 0. So they'll put it in here, okay? Then why they put the 500 in this location? I'm just assuming that this is location 0, 1, 2, 3, 4, 5, 6, and 7. So 500 is at location 0. So that's why it put it in here, right? Then the next data, 514, is at line 2. So it should be here. Then it as location number 4. So 0, 1, 2, 3, 4. So that's why 514 is at these locations. Then the next data, 32801, is at the line number 1. So line number 1 is here. So they are at the first location 0, 0, 0 here, location 0 here. So 328 belongs to these locations. I put the bracket is because it means they are not storing 328 as a number. They are storing the data at this location, at 328 location. So the bracket basically means that location is basically storing the data belongs to this 328 address location. They are not storing these 328 numbers, but actually they are storing the data belong to this address locations. Then 33C is line 3. So the line 3, then data, the word number is number 4. So 0, 1, 2, 3, 4. They are storing it here. And 444 is a line 0. Yeah. So when we are running to the memory, because they mentions that it assumes the cache is initially empty. So initially they are nothing. So every time I want to access 500, they will get a miss. So that's why 500, it is a miss. Then 514 also is a miss. So that's why when there's a miss, they will go to the memory and get the data. So when they get the data, they will get the whole block in. So basically, when you get 500 in, this location should be 501 for the data. Then this is 502. This is 503. This is belongs to 504, right? I didn't write out everything because I just want to make it faster, right? 505. This should be belongs to 506. Then this should be belongs to 507. Right, so remember every time we bring in a data, I just want the data in location 500, but I have no choice for bringing data from memory. They always bring in the whole block. So that's why I'm actually bringing the whole block in, not just the 500 data in only, okay? So every time I access 500, I get a miss because it's initially empty. They are not inside the cache. So that's why I have a miss here, miss here, miss here, miss here. So until the 444, it belongs to line 0 also, but inside here I already have the data. So what they did is when you bring in the 500, they will store the tag together also basically. So the tag 0101 000 will store together with the 500 data here. They will store the tag in your cache also. So when they come to this 444 again, they want to they know it's the line 0, so they'll go to the line 0 and get the tag to compare with this tag. Okay, they will compare the tag, these two tags, whether they are the same. After compare, they know that is not the same. So for direct mapping, it's very simple. What they need to do, they need to swap out this data. So they need to bring out this data, and then they need to bring in the 444. Okay, so just delete all this thing first. So initially I'm getting 500. So the next data coming in is a 444. So the next data coming in is a 444. So 444 also is a miss. right? So now the memory here is the new data in memory is a 444. So this is the first line of data, then this is the second data which coming in, which replace the one in the first line here. So it means 555 is now already gone. So the next data in is 444. Okay. So the 2F0 is a line 2. So they will come to line 2 also. They are also missed. So they will compare the tag. Compare the tag of this this line 2, which is belong to 514 initially, 0101 000. Right? They will compare the tag to F0. It's not the same, so they know the data is not inside. So it's a miss also. Then they will sort out this 514 and bring in the 2F0. 2F0 will come into the cache. The next one is 200. They will go to line 0. So the same, they compare the tag with the one existing in here, which is belong to 444. They are not the same also. So they need to swap out the 444 and bring in the 200. So I think I better redo everything properly. So I should put this one as a 444 to make it clear. Initially it should be a 444. Then this is a 2F0 already, right? Okay, so this should be the data inside your cache when you reach to after 2F0. So the next one going to come in is a 200. So they will go to line 0, check the tag. The tag is this one, then the 200 is this one. So they are not the same. So for direct mapping, it's very simple. When the line you want to access don't have the same tag as your data, you directly swap out the data inside that line, and then you just go to bring in the block which contain the data you want, right? As long as the tag is not the same, means it confirms that the data will not be inside the cache. So what you need to do is to swap out this line, bring in the data with one from location 200 with the whole block 200 coming in. So this data are going to be swapped out. Okay, the whole data will bring in the whole block which contain the data 200 which we want. Then the tag will also store in here 001 0000. So the tag will become the one which belong to these locations 200, right? Then the next one is a 324. So 324 is at line 0 also. So that's why they access this location and compare the tag. It's not the same, so it's a miss also. So it's a miss. So that's why 324 is a miss. Up to here, there's nothing hit yet. So everything is a miss here. So they need to sort out this thing and bring in the 324 again. So this whole thing is going to bring up. Then they will bring in the 324. Right, so they bring in the 324. The whole block contain the 324. Then the tag also need to be changed to one belongs to the 324. Okay, so the tag is this one already done. Then the next one is 518. So 518 belongs to line 3. So they go to line 3, compare the tag. They are not the same also. So means your data is not in here. Okay, so they need to swap out this line, then bring in the whole block belongs to which contain the data 518. Okay. Okay, they bring in the whole block of data which contain the data location at 518. Right, the 518 we want, then the tag also will change to the one same as the one in your belongs to a 518. Okay, so up to now is still a miss. Then the next data is a 33C, location 3. So the same line, okay, same line 3. Then they compare the tag again. Is it the same? It's not. Then it's a miss again. So again, they need to swap out this data. Then they need to bring in the one belongs to this 33C. Okay, so they bring in the data block which have the 33C. Then they change the tag to the one as the same as the 33C so also, right? So the next one is a 444. It is location 0, so they come to the line 0. Then they check the tag. It's not the same, so it is a miss again. So they need to swap this thing out and bring in the data which contain the block which have the data 444, right? Okay, so this is the new data block coming in with the new tag which is belongs to 444. Then up to here also everything is a miss. The last data for F4 belongs to line number 2. So they go to line number 2, compare the tag. It's a miss again. It's not the same. So that's why everything is a miss in the first run. So it's a miss. So I will go to going to sort out this data, right? So I will sort out this data, then bring in the data which has the 4F4. Okay, so they bring in the block of data which contain the 4F4 locations, then change the tag to the one as the one in here. So now you have completed the first run. So this will be the data inside your catch after the first run, right? The last data you have in here is 4F4 is this one. So I highlight it maybe 4F4. Then the 328 is also the last data. Then the 33C is the last data also. Then the 444 is the last data. So this is the last data inside your catch. Okay, then they said the question they mentions that it go for the catch at the end of each pass through, right? So the first pass through data at the end is this one. Then they repeated for 2 times. So now they need the second pass, right? So this will be the data for the first run. So we need to have this one in to be your to store it here. So this is your then this is the first pass, the calculations, we store it here. So for the first pass, 12 miss. Okay, hit and miss also need to copy. So we have a 12 miss. Then now start with our second pass. Okay, let's see what we get in the second pass. Okay, our second pass, the first location 500, line 0 is a miss because the tag is not the same, right? So this thing has to be swapped out. Then I need to bring in the block which contain the 500 one. Okay, I bring in the location, the block which contain the data 500. Then I store the tag inside the catch also, right? Then the second line, so again it's a miss, so because the 500 is not in here. So the second line, the second data, line number 2, 514, that compare the tag, is it the same? So it's not the same, right? It's not the same tag. So it's a miss also, which means I need to swap out this data and bring in the data belongs to contain the data location, data in location 514. So this will change to 0. This will change to the data 0101. Sorry, this is 514. Should be 010100. Something wrong in here. Why they are the same tag? Oh, it's correct. There's nothing wrong because 5. This is they have the same tag but they are in a different line. So this is the same, right? Correct. So after 514 is also a miss. Then the next one is 328 at the line 1. So they go to line 1 and check the tag. Is it the same? Yes, it's the same. So it means I get the data in here. So it should be a hit. So after they know the data is inside this line, then you need to know where, because I have 8 location in one catch line. So you need to know where is the exact locations. So the last thing they need to refer to the W. So they know the W is 000, so they know the data is at location 000. So they will come to this location and get the data they want. So up to now they get a hit, which is a 328, right? Because so the first thing they access is the line number 1. Then the next one is a tag. They compare the tag. They know it's a hit. So the last one, they need to go to the W and check which location the data is stored. Okay, so they store at this location 00, so they go here and get the data. So now we get a 1 hit. Then the next one is 33C. So they go to line 3. Line 3 and compare the tag. Is it the same? Yes, it is the same. So it means I get a hit again. So I get another hit. So then they go to the 100, which is this one, the location 4, they get the data they want, 33C. At 33C location, the data at 33C locations. Then the next one is a 444, is line 0. So they compare the tag, it is not the same. So that's why I'm going to sort out this thing. So it's a miss, okay, 444. Okay, so they bring in the data which contain the 444, right, the 444, then they change the tag into the one which is the same as the 444. Okay, The next one is 2F0, line 2. Line 2, they go to here and compare the tag. It's not the same, so means the data is not in here, so it's a miss also, 2F0. So I just swap out this thing and bring in the one belongs to 2F0. Okay, so this is the data they bring in, which is contain the 2F0, right? Then the tag also changed to the one. The next data is 200 is location 0. So line 0, they check the tag, is it the same as this one? They are not the same, so means a miss again. So that's why I get a miss. Then again, they swap out this thing and bring in the data content, the block content, location 200. Okay, they bring in the data content location 200. Then the tag also changed to this one. Right. The next one is 324, location 0 also. Line 0, they compare the tag. They are not the same, so again it's a miss. So that's why 324 also a miss. Then they swap out this thing, then they want to bring in the data block which contain the 324. So the 324 it should be here. Right? 324, then this is a 320. Okay, they changed the data to the 324, the one which contain the 324, then the tag also they change. Then the next one is 518, line number 3, so they go to line number 3 and compare the tag. They are not the same, so that's why it's 518 is also a miss. Then they need to bring out this thing and bring in the data contain the 518. So location 0 here, so this is the 518. Okay, location 0. Okay, so now they bring in the 518, the data, the whole block, then the tag also changed the same as the one. The next one is 33C, so line 3. So they come to line 3 and compare the tag, it's not the same. Then they need to swap out this line basically. So the 33C also is a miss. Then they're going to swap in the data in 33C, which contain the 33C. Okay, so this is the data which data block contain the 33C. Then the tag also they change the same one. Then the next one is a 444, line 0. They compare the tag of line 0 with this data tag. They are not the same, so miss again. So 444 is also a miss. Then 444 is a miss, so this whole thing is need to swap out. Then they will bring in the data block which contain the 444. So this is not location 4, so 444 should be here. So this is a 440, 441. Okay, so they bring in the data which contain the 444, the whole block. Then the tag also updated to the same one. The last data is the 4F4. It's at line 2. So they go to line 2 and compare the tag. It's still not the same. 4F4, so it's a miss. Okay, so I think I sum up all this thing. So overall I get 2 hit and 10 miss. Yeah, so the last one 4 is line 2, so this one I need to swap out. And I think need to bring in 4F4. 4F4 is here. Why I know it's at here? Because I refer to this word number. So this is location 0 is location 4. If you look at this word, they are basically either at 0 or 4 only. So this is 0, this is 4, right? Okay, so at the end, this will be the final content in the catch at the end of each pass. Okay, so this will be the data at the end of the second pass. So the second time, the first pass is this data, the second pass is this data, right? So you total have 2 hit in 2 run, right? So total is a 2 over 24, right? You have 24 access, only have 2 hits. So this will be your hit ratio, right? Okay, then in terms of a hit rate, you only have a 8.33% of hit rate for this question. Okay, so this is how you get the hit rate and also the contents of the catch at the end of each pass for a direct mapping catch. Okay, so I think this complete the whole tutorial questions on how to get the end data at each pass. Okay, and also the hit ratios for the whole access. Okay, sequential access of the data in the questions for 2 times. Okay, so I think that's all for this tutorial.